don't want, and if you don't want your face on the recording, please turn off your video as well. Okay, it's my great pleasure to introduce Kevin Stickney, who's from Harbro. We're very keen to have him talk because we've had a lot of discussion so far on barley's place in the brewing and malting industry, but it's nice to have a perspective from the industry that actually uses the majority of the crop, which is the feed industry. Kevin did his first and second degrees at the University of Nottingham, initially studying research on pigs and pig nutrition, moved into the commercial nutritionist in the UK feed industry for over 40 years now, starting off specifically on pigs, moving to including now chickens and other monogastrics, and more recently to cover all commercial livestock species. He's in a technical position with a general oversight and also has an R&D capacity. It's, I think, a real pleasure to invite Kevin to talk to us and give us his views on barley's place in the feed industry. Kevin.
Thank you very much, Luke. The presentation will be in two parts. The first one, which will be a hopefully not too shameless commercial expose to Harbro, at least to give you all some indication as to what the business is that I'm working for and where that company sits in the general scheme of things. Sadly, as I'm a Luddite when it comes to these presentations, I will be relying very heavily on Jesse to advance the slides for me, and I apologise for that lack of professionalism on my part. I'm not expecting any fire alarms to go off in my house. I might expect a parcel to arrive, and I hope that won't happen during my presentation. I will certainly sit tight. Anyway, so let us, without ado, advance to a bit of background about the company. Next slide, Jesse, please. So the group itself is built of three different strands, and starting from Harbro itself, that's effectively the retail arm of the business. Strathclyde Nutrition is the wholesale arm, and Transpan is the transport part of the business. Next slide, please, Jesse. And this really looks at the development of the business over the years. Essentially, it has been something of a growth by acquisition. And one such change that wasn't growth by acquisition was that which has just appeared in 2006, which was the construction of a new feed mill on a green site in Lanarkshire. And arguably that is probably the most recent, or one of the most recent feed mills to be constructed in the UK. Development continues. A lot of the development has been in purchasing small merchant feed businesses, but one never knows where the next direction might take us. Next slide, please, Jesse. The business is very much a family business, and it's now in the second generation of two families, the Kenyans and the Baxters. Although the HAR and the BRO in the company title were actually derived from the sort of originators of the business in Aberdeenshire, Messrs. Hargraves and Brown. So we took the first three letters of each surname. Those two individuals were a vet and a money man, respectively, and they were interested in developing the dissemination of technical advice and specialist feed materials, primarily to what was the beef sector in Aberdeenshire. Next slide, please, Jesse. The vision statement. All companies must have a vision statement, and this is very much ours, and it's providing solutions, and that I interpret as not only being supplying products and also processing inputs, as well as sound advice. Next slide, please. Values. Again, every company should have realistic values that they're all adhering to. And we believe that this is a robust set of core values with perhaps one thing that occupies quite a bit of my time is in the top left-hand segment, and that is looking at aspects of environmental impact of what we do ourselves in the business and also our customers and their animals do. Next slide, please. This is a general overview of where we are today, what the background was, a couple of things I've said already. As you can see, a medium-sized business in the UK feed industry, but we're quite diverse in what we do, and you'll see that a little bit later on. We do pride ourselves on innovation and quality being product and the advice that we give. Next slide, please. This reiterates a lot of those comments, and basically what we try and do, and arguably the next talk will do the third statement, hopefully some justice, and that's to challenge the norm, try and do things differently, try and ask some different questions, and also not be blinkered by historical viewpoints. And with that in mind, of course, the future is always bright and it's always challenging. Next slide, please. Principally, we focus on innovation and strong, sound technical bases, and we've always been very fortunate in probably punching above our weight in terms of the technical personnel that we employ. And one of the things I can say from my specific technical position is that brings forth quite a lot of very healthy debate. Next slide, please. As I said, we're a diverse business, so unlike most in the animal feed industry, which would probably be focused on what we call compounds, we produce a range of feedstuffs as well as selling a wider variety of materials that sit under the speciality feeds banner. We're also involved in feed processing on farm, and a little bit more of that will come later. And we also strive to try and come up with new ideas. And again, some of those will crop up in later discussion. Next slide, please. We don't do it on our own. We rely on partnerships, not only within the UK, but also in a broader sense from a global perspective in developing some of our product types. And one of the aspects that we're very proud of is illustrated in the last two words, and that's working with the University of Glasgow Veterinary School. And the overlap of health and disease management with nutrition has never been more important to the industry and our customers' success. And I'll allude to that a little bit more later. The other element that we do focus a lot on is this element of on-farm performance, simply working on the basis that if you want to make well-founded management development decisions, you must appreciate that you can't manage what you don't measure. And again, the bit in the centre where we use this a strange word that says tropper, I'll allude to that a little bit more later. Next slide, please. Yeah, I said that the Harbro business model was based on diversity, and this is alluded to here again, and will be reiterated on another slide. And arguably, we're probably, I should think, probably unique in the diversity of what we do in comparison to other feed businesses. And that's because we're involved in what we call supplements, premixes, but also the production of mineral licks and feed blocks, as well as blends for ruminants and complete feeds. So it's a real diverse mix, and they all bring their own unique challenges, but we've got to always produce them and market them from a quality perspective. Next slide, please. Yep, so an indication again of tonnage capacity, tonnage capability, where the business is based. As a business, Harbro Limited, which is the retail sector, is principally based in Scotland. But as I indicated to those who were on the call earlier, before 2 o'clock, I'm based in South Norfolk, so I would represent not the most southerly outpost, but certainly one of the 2 or 3 that are quite distantly based from Scotland. But it is indicative that we're operational in all parts of the country. Next slide, please. Diversity is indicated here with the production setup that we have in the business, and as is shown here, we cover things called blends, which I would call intermediate products for ruminants for combining with on-farm materials, e.g. such things as silage and whole crop mixtures and such like. Compound pelleted feeds are very much the standard fare of the feed industry, but we are also producing speciality meals, often in what we call coarse grist form, more of which later. And as I've said before, we produce feed blocks, buckets and mineral licks, and those sorts of items are fairly specific as a way of supplying mineral inputs with or without other nutrients, but very much focused on ruminants that are away from the farmstead. So those things that are on the animals are on the hill or on the marsh, where they're relying on relative rough grazing so that they need supplementation. The site in the top right-hand corner is an unconventional site in that it produces speciality products, which they vary from such things as coarse mixes for young ruminants to what we call fat premixes, so liquid oil carried on a fibrous matrix for ease of addition from a bag. So we do produce some unusual materials. Bottom right-hand corner, we produce specialist ruminant blends with quite high levels of liquids like molasses and distillery syrups. Next slide, please. So the structure of Harbro was split into as a group was split into 3 areas, and so is the retail sector. So the agricultural element, the on-farm sales business, of which I'm a part, is one, and that's the one with the greater number of personnel associated. The retail side, which I'll comment on in a minute, is that which is associated with the country stores. And finally, we have an international trading arm, which is, as is said, represented in 20 different countries. In that regard, they are mostly trading ruminant products. Next slide, please. So the retail stores are indicated on this particular slide. They represent a widespread coverage of Scotland down into the borders, and we sell a huge range of agricultural and other materials. And I say other materials because things like dog food and wild bird seed are strong sellers, but still from our core perspective, bagged layer feed features strongly for the hobby poultry customers that are producing eggs for their own self-sufficiency aspiring lifestyles. Next slide, please. And I have lost my prompt. No, I have not. So the wholesale side of the business we call Strathclyde Nutrition. And here's a photograph of what I referred to earlier, namely the production of mineral licks. So they will be put out in the field in this particular form in their plastic buckets to be accessed by the ruminants that are grazing away from the farmstead. The wholesale part of a business is very much separate, but it's dealing with quite a sizable merchant customer base and has its own management systems and strategies. Next slide, please. Probably the biggest growth area in the business is what we call mobile milling and mixing. And this essentially provides the middle ground between compound feed supply, so the farmer buying a pellet from a feed mill, and say scenarios where the feed is being produced on the farm using the farmer's own static production machinery. And with these sorts of approaches, the typical compound feeder user of today can be a home mixer tomorrow. We run two different types of machine, and it indicated that we have 20 mixers that are involved in what we call farm mixing, roll and treat, and that's generally into the ruminant sector. And we actually make those ourselves at Turriff. The red machine you see in the photograph is produced by a family business in Austria called Tropper, which is why we call them Troppers. And the two different machines very definitely serve two separate markets. The Tropper is very much a pig and poultry machine with high levels of accuracy of weighing and mixing, and sat on load cells, so to give that degree of accuracy. The ruminant mixing machines could be referred to as a little bit more rudimentary, but they are very much capable of adding large amounts of liquids like molasses, which ruminants are most impressed by, but also for processing things like straw to give roughage in mixes, which suit particularly finishing cattle. And both of those approaches, on both of those approaches, we have the wherewithal to alter the particle size of the bulk materials that we take in. And that is especially important for grain materials. And again, I will allude to that later. Next slide, please. This is the final slide, and is simply just a nod to our transport department, because at the end of the day, you've got to get product from A to B in a timely fashion and cost-effective manner. And whether that is a compound feed delivery, as per this vehicle, or a simple mineral premix that maybe only makes up 1.5% of a layer's ration, the haulage is the best way to get the product from A to B and actually get the value of the product realised on farm. Okay, that is the end of that presentation. So if I can ask Jesse to switch on to the second one. I'll just have a drink to sort my hoarse voice out. So this particular presentation addresses the specific question, and that arguably is the place of the animal feed industry and the utilisation of barley. But before I go into that particular area, I thought I'd just give a very simple one-slide run-through of how the animal feed industry operates and what the process might well be. And here it is laid out in what I've managed to consign down to 10 steps. And essentially, this is the process that I adopt almost without exception, regardless of where the final feed is going to be processed and to what animal it's going to be delivered. So we have a series of stages that take us through. The first one being using the premise garbage in, garbage out. If you don't know the value of what you are using, then how can you determine the quality and consistency of same in the end product? A lot of that is based on what we call wet chemistry, but nowadays significant advances in near-infrared spectroscopy have given us a phenomenal leap forward. And we ourselves run 3 NIR machines located individually at our 3 Scottish production sites in Inverness, Turriff and in Lanarkshire. And the key thing is that what we're aiming to do as we move to the second step is to look at making sure that not only do we know what the raw material requirements or values are, but that we know what the animal's requirements are. Some of those come from sophisticated IT using growth simulation modeling, and that basically allows us to select diet nutrient levels for different production stages to optimize performance parameters. And however, I mean, that sort of approach is merely a support tool that backs up standard nutrition technical experience and the sort of dialogue interaction with producers that relates general feed inputs to changes in outputs and performance. The third element is very much one that dusty feed is unacceptable. Coarse particles may be beneficial from a health perspective, and certainly some of those particles give difficulty in producing a sound pellet. So we need to know how to handle those raw materials given their different particle sizes. In addition to that, raw materials are notable for certain anti-nutrient factors, and I will allude to that later. And those anti-nutrient factors vary dependent on the nature of the feed ingredient in question. It's important with item 4 to know the cost per unit of what I call a biologically relevant nutrient, e.g. something like the digestible amino acids, so the building block of protein. We need to know what that cost per unit is, because when we look at producing a ration or a recipe for that class of animal, we evaluate one raw material against another, and it is very much a clash of cost and nutrient value that determines how much of that raw material gets used. Item 5 is a crucial element because the statutory statement or the label that goes on the feed is integral within the feed industry to legal commitment and ensures that we stand up in the face of people like the Trading Standards or Veterinary Medicines Directorate for consistency in what we are saying that we are supplying and that we are actually supplying. Item 6 is this question of particle size again, and we manage this process through grinding in some way, shape or another to reduce the particle size. But the question is, what might that desired particle size be? And I'll allude to that element again a little later. Item 7 is clearly the need for homogeneity in a feed. We need every mouthful to hopefully contain the same levels of nutrient as the next one and the previous one. The blending process is done in such a fashion that those things that have been ground meet up with fine or dry materials that didn't require processing, and we also introduce certain liquid ingredients at this stage. The next step, which is only relevant in producing what we call extrusions or pellets, is this steam and pelleting process in which materials like molasses, so a sticky material, sticky palatable material, can be added. It's part of the process for ensuring pellet quality. And then that process can be followed by the application of certain liquid additives. And in that regard, such things as enzymes, which are heat labile, might want to be applied on the outside of the pellet whilst it's cooling. And the cooling process is essential to prevent moulding of the feed material. Now, item 9 is the discharge into bulk or bag storage, and dependent on where it's going in terms of farmers' usage, and probably also to some extent the value and usage per animal will determine whether that is in a bag or bulk. Larger animals, generally bulk materials; smaller animals, smaller usage, often bag materials. They present their own different challenges. Discharging bulk material damages pellets, whereas bag material can sweat in the wrong form of packaging. And the final item is the importance of analysing the finished product to make sure it conforms with expectations. We check the raw materials in, and therefore we've got to check the finished feed as they come out. And this process is aided and abetted by checks and balances on such as checking of feed weighing accuracy, mixer efficiency testing. Is the mixer running for a long enough period of time or too long? And also an assessment of the potential for carryover. So that is the inadvertent conveyance of part of one mix into the next mix, which is something that we scrupulously endeavour to prevent. And certainly we ensure if there are any contraindications, i.e. something that should not go into the next feed. That next feed is not one that is likely to be a problem should that additive, which could be something like copper in a pig ration that you wouldn't want to spill over into a sheep ration. We have a system of scheduling of mixes to prevent that, that eventuality. So that's the background on the animal feed industry. I hope that if you didn't know already, that gives you a bit of a slice through the processes that we undertake. And now we'll go back to having a little bit of a think about one particular part of the industry with the next slide. So this is the beast itself. Good, probably on the left-hand side, and not so good on the right-hand side. And predictably, as the farmer, as the arable farmer, one aspires to grow and harvest the best possible product, but sometimes the almighty chance events or the weather conspires otherwise. Provided that the material can be proven to be wholesome, it does have a feed value, or at worst, a gross energy value. And obviously gross energy in this context could be anaerobic digestion. It could be in the form of burning and biomass. Heaven only knows why one would want to end up with that solution. And clearly the picture on the left-hand side is the desired outcome. But both of those I have had to deal with in the course of the last few months. And they're indicative of how we deal with this item that clearly is not a single commodity. Next slide, please. Yeah, so barley. My comments are somewhat guiltily. I've never really given barley a second thought with the detail and depth that I give to the more unorthodox raw materials that I encounter, e.g. cake, yes, that which we would eat, insects or pulses. And I think arguably these sort of lower inclusion materials probably have had the benefit of far more intensive research thinking from my side than anywhere else. But having now done so for this talk, I'm not certain that I'm any the better for the research, although I do have to say that my plea at the inaugural International Barley Hub meeting, that the animal feed sector commands some plant science technical development focus, resonates loud and clear, and that hopefully will come over in the following comments. Yeah, the deal is that this will be something of a literature review, and I apologise for not being a very good student and not including all the references, but if pushed, I will present the references. Next slide, please, Jessie. You'll all know this, no doubt. And yes, my comment with regard to barley is that in the horse race, barley falls one short of being placed, i.e. it's fourth on the list. It clearly scores in the more temperate climates in terms of being suitable for growing, albeit those areas have debatable levels of rainfall or even soil health, which is an element that I'm becoming increasingly interested in the current need to try and improve our sustainability. Next slide, please. So a little bit of background in terms of grain use. It's been around for a long time. As I say, it's fourth leading crop in the world. The important statement, though, of course, is that the larger share of what is grown does actually go into livestock feed. And I think we've talked about this before, that this probably the single most focus within the IBH to date has been on the area of malting and distilling. And this is my lonely voice pleading in the wilderness. The interesting thing in terms of the split of use of these materials is that the lion's share goes into ruminants. And I don't think that these proportions have changed radically since the paper from Black 18 years ago. And as you can see by adding those numbers up, 80% goes into the ruminant sector, approximately 20% into pigs, and quite pointedly, less than 1% into poultry. And I'll comment on this a little later. Next slide, please, Jesse. So my question here is barley just barley? If not, what are the differences out there, e.g. in the germplasm, which is somewhat referred to in the first paragraph, where this important paper from Schuh and Rasmussen from 9 years ago is quoted. And they looked in particular at the makeup of the starch in barley grain across 254 spring barley samples. And these were taken from this core collection, which, as I point out, was grown at what is now referred to as the James Hutton Institute. Marginal varieties, so waxy barley, which is 100% amylopectin, so much more than the standard norm. But there are these other amylotypes which have 3 times the normal level of amylose. Where do these sit in the scheme of things? Where do these sit in terms of genetic selection? And these are questions that I'm sort of throwing out because they're things that I'm not familiar with in general use. Likewise, into the next section where I refer to high and low lysine containing varieties. The relevance of lysine will come up in a minute, as will the relevance of beta-glucan. The Canadian marketplace has done quite a bit of work on hull-less varieties, and I'll comment on this and the relevance of this in a moment. But in simple terms, in the UK, my naive familiarity is between 2 and 6 row materials and those planted in winter or spring, where the share is, as indicated, larger share in spring grown material and lesser in the winter variety. And next slide, please, Jesse. With gratitude to Kirsty Richards of KWS for this, and the next slide. This merely shows what the split of winter barley is, and as you can see, predominantly 2 row feed, the little bit of 6 row feed, thank the Lord, that exists, and I'll comment on why thank the Lord later. Yeah, so that's, we see that the predominant winter barley is the feed variety. Next slide, please, Jesse. The top right section, or the right-hand section, indicates the split for spring barley, which you'll probably appreciate is predominantly the malting version. And my naive remark is perhaps a reasonable part of this crop is the go-to option for what are becoming notoriously poor weather conditions in autumn, i.e. it's what we have to put in the ground. And clearly when you look at the green rings, you can see how the acreage grown in the UK does differ, dependent, I would imagine, on those autumn planting conditions. My comment, simply because it cropped up in a meeting this morning, is I wonder what percentage of failed malting grade material from spring sowing gets fed to livestock. I don't know the answer. All I can say is it cropped up in a conversation this morning with my chairman and 2 of the nutritionists, indicating in his words, there's a reasonable predominance swilling around the Scottish market. Next slide, please. Where does barley fit in the livestock system? And in simple terms, why does it fit in that slot? And the 3 guiding factors are energy, energy, and energy, i.e. when you look at the contribution of energy that comes from the different cereals potentially available, and in this context, the first statement is an American one in comparison with maize, and simply saying that through the ruminant, there's a reasonable level of energy being derived, very akin to maize. Arguably, that's due to the negative effect of maize in the ruminant animal, and I'll allude to why that might be again later. But for pigs, the energy value is somewhere in the 80% of that of maize. And it's predominantly this question of the fibre content of barley that is the problem. And the important thing here is, and my dislike for 6-row barley in pigs, is the fact that 6-row barley generally has a far greater hull fraction, so higher fibre and a lower starch content. It mills into a form that does not aid conveying in a milling system. And also that level of fibre is notorious for reducing dry matter energy and protein digestibility. And certainly there is this strong negative correlation between energy digestibility and the content of hulls. And as I've said previously, the protein digestibility is also noticeably reduced. And the last statement is one which, yeah, I'm interested to develop and find perhaps a little bit more information about. And that's simply that it's not the fibre per se in the hulls that causes the problem, because a piece of research which compared similar levels of crude fibre coming from barley hulls with CMC, carboxymethyl cellulose, gave different results, i.e. the barley hulls inhibited growth in the target animal more so than the cellulose. And that's indicating that there's something else going on, and maybe some other form of negative element. As yet, that's one that I need to explore. Next slide, please. So how do we go about using barley generally in the industry? And the first two sections indicate the dominance of the ruminant. So that which is consuming about 80% of global production. So we've got a variety of ways of approaching it in the ruminant, and particularly this would tend to be probably a Scottish statement. So where it's not always guaranteed in the upper part of the UK to get the harvest, we find that we certainly do an awful lot of what we call rolling and treating. So this is preserving the grain, either with the propionic acid, which essentially is a mold inhibitor, or the use of ammoniation, which has a modest preservation function, but more importantly, aids in the breakdown of fibre and obviously the increase in the nitrogen content of the grain. In general, grain is processed for ruminants in this rolling or crimping manner. Rolling generally refers to what we do with normal dry grain, but crimping is where we take grain that's well before its maturity, often with 65–70% dry matter content, and flatten it through rolling systems, which is something that's both of those forms are avidly consumed by the ruminant. Across all species, you expose the barley to either hammer milling or roller milling, but in general sense, in compounding, and certainly for pigs, we would hammer mill the grain, and we do that to disrupt the outer part of the seed. So disrupt the seed coat, try and break down this fibrous hull a little bit through physical means. The barley is then, as I alluded to in the very first slide highlighting the animal feed industry, it then is a component part of what we call either an on-farm mixed product or a compound feed, with the addition of protein, fat and mineralization. Next slide, please. So this is me asking the question, what are the standard fundamental attributes of barley? And I've deliberately highlighted starch because it's the dominant component, simple as that. The other elements are certainly borne in mind. And the key thing in this particular scenario, when we're looking at the UK situation, where often wheat and barley are competing, is what else might wheat bring to the party? And the things that are highlighted are crude fibre, the various other fibre fractions, neutral detergent or acid detergent fibre, the differences, and the indication there being the items that will, I'll show you in a minute, become self-evident. I've highlighted this question of hemicellulose as the difference between NDF and ADF, and one of the important things to bear in mind is that that fraction, which I've illustrated in note 3, contains a list of items that are often referred to as non-starch polysaccharides, more of which later. Next slide, please, Jesse. The more micro or detailed nutrient values that are coming from barley are illustrated on this slide. And essentially, what I'm saying here is that the item in red on the previous slide, which is starch, is more importantly, what does that starch realize when it's fed, i.e. energy. And energy, unfortunately, is complicated in that it's not only different expressions for different livestock species, but also for different classes of livestock. And if we take the poultry question, the first number refers to the growing bird or the broiler, and the second refers to the more mature laying bird. So as you see, you can the older the bird, and the same applies to the two values for the pig, the more energy can be realized by that older animal. And that's got to do with larger digestive tract, better enzyme production, so a whole raft of things. The other item of note on this particular slide is the fact that I've indicated that the amino acids at the bottom, of which I've just listed 6/7, that they themselves in terms of their total level are important, but also of most importance is what the animal makes of those amino acids, i.e. how much is actually digested and utilized in the body rather than remaining in the gut. And the figure 75% contrasts with 81% in wheat, and that highlights the difference caused by fiber acting to reduce protein digestibility. Next slide, please. So my book values on the previous slide but one are one thing, but what about the variation around the mean? These items that I've illustrated with barley at the top and wheat at the bottom, they're most recent old crop values. So I've gone from May 1st through until a week ago, so August 10th, for the values that are associated with raw material samples that we've taken into one of our 3 labs. And unfortunately, to confuse things, whereas on the previous slides, the data were presented as dry matter basis, I've been a fool and left these as received. So these would be as fed into the animal. The other thing to draw attention to here is that these are possibly biased in the direction of being of Scottish growing origin. And I make that point because my experience is that we tend to see lower crude protein levels versus English grown material and slightly lower starch levels. And the slightly lower starch levels, as you might imagine, depends wholly on the amount of sunshine that Scotland does or often doesn't get. The comparisons there are the range of lowest to highest. And I guess one of my concerns is, having flagged up starch as being the key contributing factor within grain, one can only imagine the impact of the range from minimum to maximum starch values in terms of the energy yield of both ends of the spectrum. And not only imagine it, but also think on about the penalty for not accommodating those different ranges of values. They are crucial to the efficiency with which the animal performs. And as I indicated with the very first slide showing the photograph of the 2 samples of barley, we can get both ends of the spectrum, and they are both called barley. The two slides illustrate both cereals are affected similarly in terms of the variation in different nutrient parameters, and just that there are the differences that I highlighted on the earlier slide between the two different cereals, particularly in favour of starch and fibre. One can ask, what was a sample with almost 20% moisture doing being submitted to our lab since May of this year? One has only got to question what its wholesomeness might or might not have been. Least said, the better, is my comment. Next slide, please. So there's 60% of it in the grain dry matter. So it suddenly occurred to me that we should characterize what the starch is. And does level of the individual components mean everything? Or is it the type of starch component that is important? And all I've done here is just put a little bit of detail about the two fundamental families of starches found within barley, and point out that they are rather different. Also point out, as will be evident from the next slide, that they are dealt with differently by the animal, and unfortunately possibly dealt with differently by different species. One thing that does crop up quite a lot is the importance of something called resistant starch, and certainly there is current work going on around and about the benefits of some of these materials in terms of what they can do to what we call gut or general digestive health. And within this context, we know that resistant starch exhibits what's called a prebiotic effect, i.e. stimulating beneficial bacteria in the hindgut. And this is something that occurs in the ruminant as much as it occurs in monogastric animals, and of course in ourselves, much as you will be aware of when buying probably certain foodstuffs in the supermarket, where the material inulin is often quoted on the label. And there's some quite interesting work that I'm associated with on the Norwich Research Park, close to me here, on this very topic in humans, and out of interest into pigs as well. One little note at the bottom is the crossover between the crystalline structure and also the nature of the starch itself, in that both potentially reduce rates of digestion. And this is the differentiation between the physical form and the chemical makeup of the starch. Next slide, please. I apologize right from the outset, there's a lot of verbiage on this slide. What it's doing in particular in these references is pointing out that whilst birds and pigs are both monogastrics, their ability to use barley starch differs. And this is only one aspect of how the different species are affected by barley. And generally what we find is that within pigs, the enthusiasm is for what are referred to as low-level amylose starches. And I guess on that basis, the argument might be that to get complete digestion by the end of the small intestine, and for those who are not aware, fundamentally, digestion occurs in the small intestine, fermentation occurs in the large intestine, and everything that happens, what we call post-ileally, at the end of the small intestine, tends to largely be wasted from the animal's potential gain from that feed material. The greater part of post-ileal activity is actually negative. And certainly when one finds increased amounts of starch in the feces, that is a significant waste. Next slide, please. Okay, so this is the question of non-starch polysaccharides that I alluded to before, and essentially it's the component that's neither moisture, protein, fat, ash, or starch the component that's left over. Now, in this instance, I'm showing three of the primary cereals and looking at differentiating these non-starch polysaccharides in soluble and insoluble fractions. And the question is the extent to which the cereals are differentiated. And arguably very quickly, you see that barley is noticeably different from wheat or maize. Wheat and maize are relatively similar, I say. Wheat is still challenging in as much as it's got a significantly greater arabinoxylan level than maize, which is basically very, very limited. And arguably, when you look at the top two, they are classified as viscous cereals, as opposed to maize, which is a non-viscous cereal. Also in the top category would be oats, rye, triticale, so pretty well everything else, with the exclusion of sorghum and definitely rice. Rice is almost totally devoid of non-starch polysaccharide, which is largely why it appears in sort of remedial dog diets in things like chicken and rice, because it has relatively little impact on hindgut activity. The important difference between barley and wheat is shown in the beta-glucan column. So the soluble fraction, and it's this sort of differentiation between wheat's domination with arabinoxylan, and more importantly, the beta-glucan affecting the barley usage. And that would be regarded as the major challenge. It's the soluble fraction and the soluble beta-glucan that represents the big problem. Next slide, please. Again, a lot of verbiage. This is an indication of whether we should view beta-glucan as a friend or foe. In general, in the second paragraph, we know that beta-glucans are actually beneficial in the human, but these, I believe, are predominantly the insoluble beta-glucans and ought to be very clearly partitioned away from the items that are somewhat challenging in poultry diets, which is the comments that I make in the last paragraph. Note that it seems that pigs are somewhat immune from the challenges that poultry get from these soluble beta-glucans, and actually it's been demonstrated that the small pigs actually do benefit from the prevalence of beta-glucans by virtue of a higher predominance of lactic bacteria in the hindgut and less coliforms. And this is again deemed to be this prebiotic function, i.e. supporting the good bacteria against the bad. The important thing about soluble beta-glucans in poultry is that they cause what is called digester viscosity. And what that does is it limits the contact with enzymes and therefore reduces feed digestibility. But it also leads to some gut physiology damage as well. And that overall effect, plus what it's doing to the spill of nutrients into the hindgut, leads to significant levels of poor gut health. It's referred to in the trade as wet droppings in poultry. And arguably, that rather explains why only less than 1% of barley usage goes into poultry. Next slide, please. Whilst starch predominates, the typical feed inclusion levels of cereals, which can be up to 90%, they do bring with them some level of protein. And protein, as indicated in the previous slide, is in the form of amino acids, and particularly lysine, is of importance in the formulation. And hence, there has been work done in the past on what we call high lysine barley varieties. The only problem with this is that my reading tends to indicate that with selection for crude protein, all that is happening is there's a bit of a shift in terms of the protein moieties themselves into those that are, unfortunately, relatively poor suppliers of lysine. So actually, as the crude protein increases, you don't necessarily get an increase in the crucial amino acids, i.e. lysine. If anything, you might actually get a reduction. The other notable comment is that these particular varieties also carry a significant yield penalty. Is this still the case? Is there experimentation with high amino acid, high lysine barleys? Question mark. And therefore, in terms of where one might go to progress this sort of improvement potential is to look to change the relationship of albumins and globulins to prolamines, with albumins and globulins being higher in lysine per unit of protein. The unfortunate thing about those particular proteins is that they're in the allurone layer, and that is also linked to cellulose. That reduces lysine digestibility. However, some level of grain processing can overcome this. Next slide, please. And this is really me having to acknowledge the fact that 80% of cereal goes into ruminants, and therefore, should we not be looking at barley as a particular feedstock with ruminants as their destination? If that's the case, then here are some elements that are key to what would be a good product for ruminants. And in this regard, we have to think in reverse to monogastrics. Monogastrics want good digestibility of starch. In contrast, the ruminant does not want overly fast breakdown of starch in the rumen, because the threat is of something called acidosis. And this is a particularly serious condition in ruminants. Affects feed efficiency, likely to cause laminitis, so locomotion problems, but also there's a high rate of attrition, sadly death, from uncontrolled acidosis. So we need to think about the rate at which barley starch is broken down in the ruminant very differently to how we do in the monogastric. And the statement that comes out of my reading around this subject is that whilst we're always aware of hard and soft wheats, I don't think I was particularly aware of the benefits or not of hard barley. And clearly there are particular lines that have a tendency towards greater or lesser hardness, and the fact that there is this relationship between hardness and digestibility. The key traits for barley into ruminants are listed at the bottom, and they are very strongly scored as being beneficial. And I would argue that clearly, in terms of the selection for new varieties, I'm not sure that they are necessarily selected for. The next slide is merely an illustration of the relationship between feed digestibility in the rumen and the hardness element. Next slide, Jessie, please. And basically, dry matter digestibility improving is not good news in the ruminant. So what one looks for are these harder endosperm varieties, which are those that are favoured by the HA-M allele. Next slide, please. This is a summary of my wishes, let's say, were we to split out barley selection for livestock into two categories. And they are summaries of where we might have been in the previous slide. So that's just for summary reference. Next slide, please. I've just tagged on a few additional thoughts. The first one being the feed industry routinely uses exogenous enzymes. So these are enzymes that we're putting in the feed. I refer to the fact that some are sprayed on pellets. The problem with this is that because barley is number 4 on the global growing list, all of the enzyme company emphasis has essentially gone into wheat and maize. So finding an enzyme which has got a particularly good level of beta-glucanase, for instance, is quite difficult. Finding one that's actually registered for use in animals is even more difficult. So there is a partial solution, but it's very limited. Second item, there exists something which is called new crop barley problem. And this is certainly in the pig is made manifest by feeding what we call green barley, so barley within 3 to 4 weeks of harvest. This particular material is deemed to cause scouring conditions, so diarrheic conditions, and it's also deemed to have adverse effects on breeding. in the mature animals. Is it really a problem? Is it something else that coincides? Is there a change in the makeup of barley as it dies over the 2, 3, 4 weeks after harvest? A question mark. Another one that annoys me when I see samples of barley, the amount of awns that are still present. Is this a new design of combine harvester problem? Is it a variety problem? It's certainly a nuisance because the awns are always nothing but dilution of energy. They are also potentially damaging to the surface epithelium in the gut. And finally, I guess my plea, which is the original plea, should we be looking at specific barley varieties for use in animal feed? And is there a demand from anybody other than this speaker? And just as an added comment, we as a business working with Glasgow University are currently looking at measurements of fecal starch in dairy and beef cattle, i.e. how much goes straight through the animal, purely because we feed the wrong form of barley. And the last slide has my details on, I believe, Jesse. I apologise for the length of the talk, but I hope it's been interesting and informative, and please do have a look at the details, and if you want any follow-up, please do get in touch with me. Thank you.
Oh, thank you. I wanted to just check, is there, I don't think there's any questions in the chat. I don't think there are, but I was wondering if I could just kick off maybe with a question that relates kind of to your last slide. Is there a value given to better quality barley when purchasing in feed mixes?
Yeah, thanks, Luke. It's the one thing I didn't comment on, and that's yeah, what are the trading parameters for barley? In general, the trading parameters are moisture, bushel weight, and impurities. So the answer is yes, but it's in reverse, of course, because the comment that was made to me this morning is what difference is there between the 64 kilogram per hectolitre of barley that was being used by a certain customer last year and the 58 kilo material that is currently being shown in tests. So in other words, the answer is, if you were to trade that in the market, that's a penalty. So you're obviously incurring a penalty for poorer bushel weight material. Likewise, if it's higher moisture than 15%, there's a penalty. If there's a higher impurity level than from memory or admix greater than 2%, there's a penalty. So the answer is there's a negative reward, i.e. you get penalised less.
I do, yeah.
But the problem then is that we have that sort of physical barometer called bushel weight. And one of the questions I get asked every year at this time of year is, does bushel weight actually mean anything to a nutritionist? And the answer is, when you look at the work that's been done, and there was some particularly good work that was done in across all species to look at physical measurement parameters and how they're related to energy. And in short comment, there really was no good correlation. Now, if you relate bushel weight falling to reductions in starch content and elevations in fibre, then by dint of what I've said in the presentation, there must be a reduction in energy. So what we see, whilst there is not something that would say 64 to 63 to 62 has units of energy reduction, 64 to 59 does, in my parlance. But it's not a black and white science, because you will get, I mean, certainly when we look at deriving energy values for cereals, there are there are equations utilizing fundamental measures like moisture, starch, NDF, and then adding in things like ash and protein and oil increase the R squared. But principally, it's starch and NDF and moisture. So if you take those measures, you will find, and certainly with the way that we put diet formulae together, we basically pluck the information that the lab has realized for the barley, feed it into our formulation system. It then utilizes starch, NDF, moisture, and calculates an energy value. So it is doing that, albeit with an equation which is ish. My understanding of the R squared is it's 0.7 something, and anybody that's worth listening to shouldn't get out of bed for much less than 0.9.
Yeah, thanks. Robbie, you got a question?
Yeah, Kevin, nice talk. Thank you very much. There's about probably 5 million tons of barley grown in the UK each year that goes towards animal feed. What's the total tonnage of animal feeds in the UK?
Interesting. I know it's a lot less this year than it was last year and the year before because of the lack of livestock. I would have to get back to you, Robbie, but in terms of, I'll answer in a slightly different way. If you look at the tonnages of ruminant versus monogastric feed, the predominance would be monogastric. And I would imagine those numbers are of the order of 2/3 and 1/3. And if you look then at the monogastric feed and say, what percentage of that is poultry, I would say to you that the relationship is probably the same, approaching 2/3, 1/3 poultry to pig. If you then look at poultry and say, what's the predominance broiler versus layer? Probably 75-25. And remember my comment about how much barley gets used in broiler diets and in poultry diets generally. So you've got a relatively small usage in poultry, and poultry is the predominant amount of compound feed. So you take your 5 million, and I could guess at, is it 20 odd million, 25 million?
Okay. I had another question, if you don't mind, if anybody else doesn't mind it as well, and that is, as part of the animal feed industry, do you partner with organisations like SRUC or IBRS in Wales to evaluate the greenhouse gas emissions from feeding with different feedstocks?
No, with those individuals specifically.
Or other individuals?
Yeah, I mean, in terms of SRUC, SAC are the ones that are running the sort of environmental metrics, but so are, unfortunately, so many other different businesses running those environmental metrics. And the concern that I have is the degree to which those metrics are sufficiently all-consuming, by which I mean, for the lion's share of my client base, which are what are called home mixers, my interest is in growing something that benefits the soil for the next crop. So hence my extensive dialogue with BT and Etta on pulse matters, but also thinking about materials that are sequestering actively. We as a business have long since had a focus on environmental impact of feed materials, and that's largely come about by part of the feed body AIC. I have a sister body called Feed Advisors Register, and that's been in existence, crikey, for probably approaching 15 years. And one of the requirements of the Feed Advisors Register, which if you don't have grandfather rights like me, you need to be a member of, is that you've got a clear understanding of how feed materials impact on the wider environment. So we're not quoting carbon dioxide equivalents on our feed materials, mainly because the database is just so poor. It's good, it's a good start, but it's poor if I want to use some raw materials that would be regarded as diverse, like lower grade barley or even field beans.
Yeah. I've got George Laurie here with me. He's got a question as well, Kevin.
Hi, Kevin. Sorry, I was a wee bit late in coming in. But thanks very much for your talk. Kevin, on going back to Luke's question, you talked about the premium or lack of premium, and then you went on to bushel weight. There was some work done about 5 or 6 years ago with the HDB. I was part of that, where they were looking at bushel weight and livestock performance. I need to go back and look at some of the notes, but the general comment was until the bushel weight went really quite low, there was very little difference. I mean, you quoted 58. I think it was even lower before you started to get some tangible difference.
Yeah, agreed. Yeah, agreed, George.
So,
I mean, it is a broken stick
yes.
Effect that you very definitely see. Agreed.
Yeah, but going back to your, is there a will for us to grow or a specific feed barley? I would say yes, there is a will to grow, because there's far too much at the present moment where you just get the rejected malting barleys, which have maybe had the wrong nitrogens put on them and things like that. So I'm chairman of the International Barley Hub. Robbie and I work together, and I would certainly back more research into specific varieties that suit the feed market. And I think that's something that we need to concentrate on. The big problem with that, though, is soon you start growing specific for the market, the farmer will be looking for a premium. It might not be a malting premium, but he would still be looking for a premium if that was to come. Do you think that case will ever come?
George, I think I was very disingenuous towards you when you weren't in the room, because I said I thought I was a plea from the wilderness at the inaugural meeting at Scotch Whisky Distillers. Now, I recall you and I had a conversation there where you were very supportive of my position and I of yours. So there are two of us pleading in the wilderness. I would like, just because of what I sort of unearthed with producing this talk, there's so much where I know that I can respond better to my customers that ask me the question, what should I be growing? And that's not the same as the one you're asking me, because clearly my customers are grower feeders. They're probably net buyers of grain rather than sellers. And therefore they've got a vested interest, but they would certainly be absolutely clamoring for a feed barley. Absolutely they would. And particularly given the amount of material that goes into ruminants, if we were to stream out a type of barley which fitted the ruminant digestive requirement, I have no doubt that that would be beneficial. Would it be saleable for a premium? Crikey, it's entirely dependent on us getting the message out more broadly and saying, this is what happens when you feed rejected malting. This is what happens when you feed barley, in inverted commas. And it may be that the piece of work that we're just starting, which is actually looking at what comes out of the back end of a cow, an invidious job, I admit, if that shows up what I think it might show up, and we then say, how much starch is being wasted? How much land mass was used to produce that starch? How much of that starch could have gone into the human population? How much could it have been reduced had we have used a starch which was more applicable to that animal?
Oh, thanks very much, Kevin.
There's a question from Christoph, Doctor.
Yeah,
I can't hear you.
No.
There's a question, but
type the question in the box.
aye, good idea.
Can I ask a quick question in the meantime then, which
Please
just
do.
requires a quick answer? Did you take account of the land quality for growing barley compared to growing wheat in any of the calculations that you have? Or the fact that a lot of the barley, which would probably be included in animal feed, was, as I think just mentioned, rejected from malting? So would have, for example, been grown for low protein, particularly in Scotland?
Yeah, I mean, there's no amount of low protein samples that we see. And one thing I forgot to highlight is the fact that of course, in animal feed parlance, protein equals nitrogen times 6.25. You will be working as nitrogen times, gosh, probably 5.38. So just remember that that correction needs to apply to what I talk about as being low protein. Yeah, I mean, there's no doubt that we grow barley because we grow barley on land that is somewhat marginal. And my current enthusiasm is, of course, God forbid I might even say this and get absolutely blackballed by IBH. One of my areas of enthusiasm, of course, is hybrid rye, which is capable of growing in even more marginal land with even lower inputs. And you can now shoot.
Don't worry, Kevin, you'll be delighted to hear that we've actually just collected and made a rye collection here.
You're
talking with some breeders about doing a rye program. Christoph's question's in the text now, by the way.
Yes. Okay. A couple of questions come through from Christoph. Is barley always fed as unprocessed grain, or do you also feed germinated grain, either germinated by a company or kiln dried, or by the farmer? Allow you to modify the starch and the beta glucan potentially.
Yeah, good question, Christoph. I mean, the answer is that yes, I have fed germinated grain, but it's normally by accident because it's sprouted in the field. And working on the premise that we grew it and therefore we've got to feed it, and we're not prepared to dispose of it for lesser income, that is the only time that it really gets utilised. As far as I'm aware, I know it has been used. It's been used in the Middle East as a form of green forage, which again is not the same thing, but it's, yeah, I mean, it's interesting to and probably the barley sample that had 19.9% moisture from our analysis had probably got fairly close to sprouting. I wouldn't be surprised. So the answer is no, only accidentally. Clearly, probably it would be useful to have a look at this question of what the benefits are in terms of the change in those, not anti-nutrient factors, but certainly say negative elements, and see how we might harness that material. Clearly, from everybody's perspective, we take the grain preferably and either take it, dry it, or preserve it. But whether there is a sensible method of taking the germinated material and then still being able to use it in a steady state, i.e., can we kill it at a particular point? It's out with my brief, but certainly will cause me to read further around the subject. So, yeah, thank you for a most interesting question.
There's another question in the chat from Namuk. Apologies, Namuk, you got gazumped there. Do you have a preference in terms of grain colour at all? Do you observe any differences in say, a blue Alarone or whatever in terms of feed quality?
I would say the answer's absolutely not. Whether that is an indication, and I'm aware of from memory, probably purple seed coat barley. Is the animal going to select against coloured feed? We generally presume that the animal mostly works in monochrome, and dependent on the amount of the darker colour that might be there. So this could actually be a question which is, say, related to do animals select for or against sunflower husk? Because overtly you've got something which is black against a beige background. Often that's a question that goes into the laying hen arena, and yeah, we do know there will be some selection pressure against something like sunflower seed husk and in favour of maize chips, but that's about as far as we go, I would say, with how they would select on colour. I've done some work with turkeys in the past for Bernard Matthews, where we dyed the feed different colours, and I think they were blue, green, red, and no dye at all. I never did see the results, but I can assure you that turkey feed tends to be uncoloured. That probably tells you the answer. The colour cost money, made no difference, would be my reading between the lines.
Okay, I think we're getting close to the end here. There was one. I just squeeze in one last question from Soren here. Is it costly to use feed enzymes such as beta-glucanase and phytase to solve the problems?
No, if you generally feed enzymes are widely used in monogastrics, less widely used in ruminants, if at all. They can be used a little bit as processing aids, so you'd find them included in silages, for instance. But they are widely used. But my concern that I expressed as regards to the NSPases or carbohydrases is that they are predominantly directed at the aragonous islands, so those which predominate in wheat, rather than the beta-glucans. Almost invariably, you get what's called side activity, secondary activity. So even an aragonous island will contain some beta-glucanase. The argument is, if we were enzyme treating barley, surely we would feed a beta-glucanase with a little bit of aragonous islandase. And that's not the way. And sadly, the issue with the enzyme companies is they want to deal with the mass market. So in other words, go back to the cereal grown globally, maize, wheat, they catch all of the business, unless you are dealing with really unusual specifics with the enzyme companies, such as washing powder.
Okay, I'm afraid we're running out of time. Kevin, thank you very much for your time, and the presentations generated a lot of questions, a lot of interest. Thanks again, and thanks for everyone. We have another talk in a fortnight's time, I believe. So please do stay tuned.
Actually, Luke, I should mention the talk in a fortnight's time has been cancelled because the speaker is travelling overseas.
Okay, so month's time then.
In a month's time, correct.
Yep. Okay. Thank you, and thanks to everyone. Cheers now.
Thanks all.